Welcome everybody. My name is Davide. I am a global cloud solution architect in Microsoft. As Gilman mentioned, I actually used to be an MVP for application lifecycle management, or as we would call it now, DevOps. And I'm normally focusing on cloud native technologies like containers, microservices, serverless, those kind of things. And I'm also an MMA fighter. So he mentioned about the evaluation forms and feedbacks. So, keep in mind that don't be too rough with me, right? No, I'm kidding, of course. All right. So just a little bit of introduction. In my section, I will cover some basic things and also some more little advanced things. But I want us to be on the same page, so bear with me if you already know some things. Whenever you plan your journey to the cloud, there's some steps you need to take, and there's some end results you expect. And whatever you make, it can basically trigger way more workloads and way more steps ahead. Whatever step you take as your first step could be rehost, refactor, re-architecturing, just a journey that starts. Normally, when companies adopt cloud, it's very difficult to start with a fresh project going just cloud native. I think the main point of this slide is whatever is your entry point, make sure that you can execute through the pipeline. Every entry point is a good entry point. Whenever you want to go to the cloud, that will be quite difficult to have the demo. Make sure that you implement some DevOps pipeline across your development and operation and deployment, because that, whenever you go to the cloud, is even more important than when you are on-prem. DevOps is already important when you are on-prem, but if you go to the cloud, is the go-to strategy and methodology. As I mentioned before, there's multiple things you can do, but when we talk about app modernization, we normally talk about three main pillars: the refactoring, the re-architecting, and the rebuild. As I mentioned, if it's your first project or you're quite new to the cloud, most likely you will not rebuild the application from scratch, but you will most likely go for refactoring or re-architecting. And this may seem quite similar, but are actually two very different ways to approach the same problem or the same concept. When we talk about the refactoring, in this slide it talks about container. It's not necessarily container, but it's way more than just rehosting. As you see before, rehosting just is taking your application, putting it on a VM on the cloud, and that's it. So most of the things basically don't change with respect for your on-prem environment. But then when you start refactoring your application, taking into consideration, for example, moving to containers, that it's a whole new world. Maybe your application don't even need code change. Sometimes it doesn't, but then all the rest is new. So you need to consider the container environment, most likely a container orchestrator, how to manage the container, how to deploy the container, or how to monitor the containers, et cetera, et cetera. So it's already a big step that is, again, may not require application change, but may require you to change your practices, your methodologies, et cetera. And of course, if we move up, then it starts to be even probably more challenging, even though most of the time more rewarding. Because when you start, for example, splitting your application into microservices, then of course there's a huge need of application change. And of course, if we want to go even further, talking about serverless, then most likely you need to take your application logic and completely remake it in a serverless way. So again, when we talk about app modernization, it's the three boxes in there. Of course, then you can also go even further, but then basically you don't have any more control on your application because you go for a SaaS model, which means that you just use something that is already existing. You may have some minimum space for customization, but that's it. All right, so what is a container? Probably every one of you knows already, but just for a quick recap, hosting your application in a container is substantially different than hosting in a VM, even though it may look the same. And unfortunately, that since sometimes it looks kind of the same, I've seen many people in either small organization or even enterprise treating containers as VMs. And this is one of the most wrong thing you can do. You need to consider container as a different kind of environment. And the reason being that when you go to a VM, you need to manage everything. You have full control over the operating system. And basically, if you put more applications inside the same VM, those applications share the common layer of the operating system, all the libraries installed on the VM, and they share the same file system, and so on and so forth. When you go for a container instead, while some of the components are still shared, like the kernel for the operating system, but basically all the dependencies can be containerized inside the same container, and so they are totally independent one another. A common example is when you go for like a legacy.NET application, for example, and you have the .NET framework installed, you can only have a certain version of the .NET framework. Or if you use some libraries in the GUC, the libraries are there, and all the applications take dependencies on the same libraries, right? You cannot split. You cannot have two versions of the same library unless it's designed to. Of course, when you go for containers, as I mentioned before, everything is independent, so almost everything. But the dependencies are, which means that even if you have 10 containers on the same host that need to use 10 different versions of the same library, there's no problem because that is the context is inside the container. There's a slight difference between Linux containers and Windows containers, because for Linux containers, basically they share only some components of the kernel. All the rest is inside the container. For Windows containers, there are two modes, and in one is basically the same. It's total isolation. But for the Hyper-V containers, they share also some other features inside the operating system, so that takes some dependencies. But normally when we talk about containers, unless you have to modernize legacy application that run, like for example, on full .NET framework, so you need Windows, normally we talk about Linux containers. When we talk about container, actually the container itself is the running version of your application. To start with containers, you need something called container image. And container image is basically a file or a set of files, if you want, that contains the full definition for the operating system to use, the dependencies you need, your application files, etc. And you cannot have a container without a container image. So you may think like a container, and the relationship between container and image, like the relationship between a class in your application and an instance of that class in your application, right? So whatever you instance a class, you create a in-memory instance of that class, which is not the original class, right? The class is just a definition of what that instance will do. Same thing for the container image. Everything starts with a Docker file, which is actually where you include all the steps for grabbing the OS that you need and all the operation that you need to do on that operating system, on that image, to install your dependencies in your application. And what that Docker file does when executed with the Docker command is, first of all, retrieving the base OS image that can be, again, Linux and Windows. And then, as I mentioned, start processing the Docker file and installing all your dependencies. Could be runtimes, could be middlewares, could be other libraries, etc. And then, in the end, on top of that, it basically publishes your application inside the image. And when you have that, you have your final image. That can be done manually, can be done most likely with a CI/CD process, which means that you build your image and your application together in an automated way, which is the preferred way. When you have that in place, so when you already created your final container image, that of course you can version, then you're almost ready to go for running your containers. So what do I need to run a container? Well, as we said, of course, we need the container image. Without that, you don't go anywhere. You need a container registry, which is a repository of your images on which, when you need to run a container, the container runtime, which is the actual component that will run your container instance, will grab the image for. So you need at least these three things to run a container: container image, container registry, and container runtime. And actually, someone could argue, no, when I run my containers on-prem, on my laptop, for example, I don't need a container registry. But actually, you implicitly have a container registry. It's not like a Docker Hub or Azure Container Registry, but it's still a repository of image that you have locally on your laptop. Because Docker must know where to pull the image to create your container. So you need these three things to run a container. A brief thing about microservices, because normally, even though we can use containers to modernize existing application, as I mentioned, and sometimes, most of the time actually, they don't really require any code change, if not minor things. Containers are even more important when you try to host microservices. So what are microservices? Very, very brief. Microservices are, as the name say, some small services that compose a bigger application. So in a normal monolithic application, you have everything contained in the same package, and when you need to deploy, you need to deploy everything. When you need to make a change, you need to do some regression testing on the whole thing, and so on and so forth. With microservices instead, you can split your application in many different parts that can be versioned independently, can be deployed independently, can be scaled independently, and most important, can be developed independently by different teams in different languages with different dependencies. And because they are normally containerized, even if they have different dependencies, as I mentioned before, on the same library but different versions, that's not a problem, because you can always deploy them on the same host if you want or if you have to, and that will not cause any problem. So as I said before, one of the benefits is the independent scalability and independent hosting on different hosts. And most of the microservices platform have also some auto-healing features, which means that if one container or one microservice fail, it can spin up another instance somewhere else in another host. Or if the whole host fail, automatically what was deployed on that host is spread in the other host until that host comes back or a new host is provisioned. From everything we said, I think it's already quite clear on how containers can help modernizations. But again, just to reiterate that, we have two ways that we can use containers in those kind of processes. One is taking an existing application, containerize it to take advantage of the whole container ecosystem, having multiple application dependencies, blah, 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 all the things I already mentioned. Or we can use it for hosting containers. By average, we've seen that when you containerize your existing application, each host often runs an average of 8 different containers at a single time, where most likely when you use VMs, you normally use 1 or 2 application maximum in general. It's also using containers and proper DevOps practices that normally comes quite together. In average, we've seen an increase of 46 times the frequency for code delivery than using normal monolithic applications and non-proper DevOps practices. And this is because when you go for containers, it's much easier to deploy, it's much easier to have even different version on the same host, etc. And because of that, we have some huge clients doing very, very big things on containers. You can for sure recognize few, at least, of the brands in there. Those are just a small subset of the client doing that. I will talk through a couple of things later. So how Azure helps? Azure helps because we have a lot of different services for containers, not only the container registry I mentioned, but we can host our containers in different services. We already seen container instance, that the one I just showed you, to run your containers directly on Azure platform. But we also have App Service. App Service is a service that normally is used for hosting web applications. but you can also use it for hosting containers. And it's the perfect solution when you have maybe just 1 or 2 containers, like most likely from existing application that you just containerized, because it doesn't require you to learn any orchestration capabilities. You still have auto-healing, you still have auto-scaling and enterprise features. So I'll talk a little bit about this later. We have Service Fabric that normally is used for .NET and Java microservices without containers, but of course you can use it for hosting containers as well, and it has much more powerful orchestration capabilities than app service, but it's easier to learn than Kubernetes. And then of course we have Kubernetes and all the other ecosystem. We have Cloud Foundry, we have OpenShift, and all the other open source and first and third party tools you may think of. And of course, as I mentioned, you can host your images in Azure Container Registry. You can use still Docker Hub if you want, or if you have any other private repository anywhere in the world in your on-prem environment, on Azure, SaaS, you can always use that. So I talk about Azure App Service, and I want to talk about a little bit this case. So the Nobel Prize, I think every one of you know the Nobel Prize, decided to revamp their website a few months ago, and they decided to go for containers. So, of course, as you can imagine, when before the Nobel Prize nomination and before the awards, there's a lot of people visiting their website because they want to know who's been nominated, who's been awarded, when the award will be held, et cetera, et cetera. So there's a huge amount of people. We're talking about millions of people visiting these websites. But on the other hand, when there's no Nobel Prize nomination, or when there's other time of the year, I wouldn't say no one visits the website, but the traffic is much lower, let's say, right? So they wanted to have a platform that can support the millions of users that visit the website, but also that allow them not to pay for a lot of money when there's few visits on the website. So for this reason, they decided to go to App Service for Container. But of course, they wanted to have all the enterprise capabilities and features that they need. And the good thing here is that App Service actually offer all the capabilities they needed to. So using these capabilities, basically what the Nobel Prize did was implementing these enterprise features and running their container on top of App Service. And of course, they have some other Redis cache, they have some security, they even have some connection to the on-prem systems to retrieve some data. And then, of course, all the other enterprise features, as you can think of, like CDN, they use, of course, Container Registry, MySQL to backend, etc. So, and this is done only on the container runtime, just with App Service and their enterprise features. But of course, there's also some more, advanced use case, like when you want to use Kubernetes. I think every one of you knows Zeros, and you may have heard of their DocuShare Flex service. It's an enterprise, let's say mid-business to enterprise level service for document management and legal document keeping, etc. So before implementing container and Kubernetes, they had to provision a set of VMs for each and every client, especially when they requested some demo. And they use a Java-based stack with a Postgre database and some, of course, other shared services. But the main application logic is in Java, and the data store is in PostgreSQL. So as you can see in the image, they were, as I said, they need to create for every customer, even when they requested a demo, a new environment. And for some reason, due to configuration, complexity, etc., this took about 24 hours. So it means that I am the client, I go to their website or to the sales representative, I request a demo, and I need to wait 24 hours to be able to access the demo. So this is, of course, not the best thing, especially for a client. So what they did was containerizing the application with literally zero code change. And they moved the PostgreSQL from single instance per VM to a shared PaaS service on Azure, because we have that. They containerize the Java part, they put it on AKS, and again, with no code changes, apart from connection strings and those kind of things. And they put the web tier on top of Nginx. So doing that, they switch from 24 hours to provision an environment down to 10 minutes. This is the current situation. And they are actually working on some other automations. And in test, they are already able to go down to 3 minutes to provision an environment, a full environment. So from 24 hours to 3 minutes time, which as a client, then I would say, okay, I can wait 3 minutes for a demo. Maybe I cannot wait for 24 hours for a demo. I just want to leave you with some references. Again, we will share the slides, so no need to take a photo, but you will have that later. So remember that you can deploy your container on App Service, on AKS, on Service Fabric, on Azure Container Instance, depending on your needs. We have the full plethora of services for you. But the main thing here is that do app modernization, no matter you do it on Azure, but of course better if you do it on Azure. Container is a quick way. It adds some overhead. The thing I didn't show is how to monitor and how to inspect your containers. It adds a little bit of complexity for debugging, unless you're running .NET applications. If you run .NET application in containers, you can remotely debug your application inside a container with Visual Studio and VS Code. There are some other plugins for other frameworks as well. So enjoy your container journey, enjoy your app modernization journey, and sorry for overrunning, but thanks for your attention.